So 14 part A, we've got a massive trig equation which we need to turn into another massive trig equation. Let's see how we get on. Okay, before we leap in, it's worthwhile just checking what's here and what's not here anymore. Sine 2 thetas are still here, but what's gone, tan's gone, and actually so has sine, because sine has been transformed into cos. Well, that's a fairly easy transformation because sine squared plus cos squared is equal to 1, so that's going to come into it somewhere. But therefore we shouldn't start attacking the sine 2 theta, but we should start attacking the other terms. So tan theta here will convert to sine theta over cos theta. So this becomes 2 sine theta over cos theta. I'm going to leave the 8 cos theta alone because it is part of this answer here. But the 23 sine squared theta I'm going to transform into 1 minus cos squared theta using the Pythagorean identity there. We've got another bracket, and that is equal to 8 sine 2 theta. Now, 1 plus tan squared is sec squared, and sec squared is 1 over cos squared theta. So this is divided by cos squared theta. Well, I've got a cos theta on this side of the equation and a cos squared theta on this side, so I can get rid of one of them on either side. Multiplying across by cos theta, I get 2 sine theta cos theta, and I'm going to multiply this guy out as well, 8 cos theta plus 23 minus 23 cos squared theta is equal to 8 sine 2 theta. Well, if you look in your formula books for the double angle formula, this is sine 2 theta as well. It would be a mistake to cancel these two terms out because you're removing them from possible solutions of the equation. We can cancel constants out, but we can't cancel these variables out. So they're going to have to stay. So if we move all of this onto this side, it's all under the charge of sine 2 theta, and we get 0 is equal to, so if we look at the cos squared thetas first, this is 23 cos squared theta. Now the cos thetas, this is negative 8 cos theta. Now the numbers, we've got a positive 8 and a negative 23, making negative 15. And that should be the answer where A is equal to 23, B is equal to negative 8, and C is equal to negative 15. And that's the full answer to part A. So part B, we've been asked to solve the first equation, which we've now converted to our new equation, and we've asked to solve it between 306 degrees and 540 degrees. So if this is true, then I can say that sine 2 theta equals 0 or this lot, and both will offer different solutions. Now, to solve this first one, I'm going to say let 2 theta equals x. So the equation we've got to solve is sine x is equal to 0. So when is sine x equal to 0? Well, x would have to be 0, 180, 360. I've written that number because if I need to find theta, I have to divide x by 2. And the ones which are in range, I'll underline. So these are our 3 answers, and all of these aren't in the range that they've stipulated, which is 360 up to 540. So that solves that part of the equation. Now let's go on to the quadratic. And this quadratic actually factorizes. And you get this. So therefore I can say cos theta equals negative 15 over 23, and cos theta equals 1. So if we look this value up on our calculator, we get that theta is equal to 130.70 degrees. So here's a simple cast diagram of the angle that we've got, which is 130.7. There will be another one of those angles here, which works out to be 229.3. So far, neither of these two angles meets our requirement of 360 to 540. And the cosine wave, we know, repeats every 360 degrees, which means that only one of these values is in range. Now, our last remaining solution of cos theta is equal to 1. Well, cos theta is equal to 1 will be at 0 degrees, and again repeating at every 360 degrees. This will be 360 and 720. So 720 is out of range, but we've got the solution for 360 already, but I'll underline this one here as well. And that should be your answer to part B. But I've just noticed here that x cannot be 450, so I'm going to lose this answer as it is not a possible solution for our equation. So just bringing all the results together, theta is equal to 360, next one up 490.7 and 540. And those are the answers the question wanted.